Okay, you got to figure it out. What's your answer?
3.
Yep. Because 9 to the 1/2 equals x if we loop-de-loo it. And we just talked about a fractional exponent is a radical. So the square root of 9 is 3, and 3 to the first is 3. So there you go. Anybody have a question about that? Okay, now we've got a little bit bigger, more involved problem. Those two were pretty easy. And this one's easy too, it's just more, it's gonna take a little more. I have a logistic function. Its initial value is 25. Its limit to growth is 100. And it contains the point -2, 149ths. This is a logistic function. So you are going to write the equation for the logistic function whose initial value is 25, whose limit to growth is 100, and containing the point -2 over, or -2 comma 149ths. Now, obviously the first thing you need to do to get started is to remember that a logistic function looks like this. That is the format that we are using when we write our logistic functions. Your job is to figure out A, B, and C. All right? Who remembers? We did actually quite a few of these a long time ago. Who remembers anything?
Is the limit to growth 100?
It absolutely
sorry,
is.
No, A is 100.
That's right. That's exactly right, Jacob. The limit to growth, as long as this number right here is a 1, and it is because that's the way we're setting it up, as long as that number is a 1, your limit to growth is going to be your numerator. So right off the bat, no work necessary. We know the numerator is 100. All right? Now what? Who remembers? Now it gets a little bit more complicated. Remember?
Does x need to be 0 and then y needs to be the initial value?
Now, you know what Jacob's doing? Jacob's doing a very smart thing. It looks to me like he's referring to his notes, which is exactly what we should do if we don't know how to do something, right? Go back and look at your notes. So Jacob, you're exactly right. The initial value, that's another way of saying y-intercept. So when we say the initial value is 25, that means that the point 0, 25 is on the curve. The y-intercept is 25. So if I take my equation, I've already got 100 put in. If I take my equation, put 25 in for y, and 0 in for x, things kind of fall into place. Because what's c to the 0? Somebody other than Jacob, what's c to the 0? 1. So this basically isn't there. It's a 1. So we have 25 equals 100 over 1 plus b. So cross multiply or bring this denominator over, or however you want to think about it. We have 25 plus 25b equal to 100. So 25b equals 75 and b equals 3. So now in my equation, I have figured out that my a is 100 and my b is 3. And there is only one more thing to figure out, and that's C. Well, what am I going to do to find C? Not Jacob, someone else.
Plug in the point.
Exactly. So I'm going to take my other random point. This is not a special point. The initial value is a very special point. It's the intercept. This is just some random point. So I'm going to plug it in. So 149ths equals 100 over 1 plus 3c to the negative second. Remember, x comma y. So you're putting in 149 for y and negative 2 for x. Now I'll cross multiply. I'm not scared about the arithmetic. This is for grade day. So 300 c to the negative second equals 4,800. Everybody still with me? I'm going to divide by 300. Let's see. 16. Now what am I going to do with that? C to the negative second is 16. How can I solve that? You got some options. What's your idea? Who has an idea? Caleb Grossi, got an idea?
Make c to the negative second 1 over c squared.
Beautiful. So 1 over c squared equals 16 over 1. I can just cross multiply. Divide. And what is the square root of 1/16?
Going to be 1/4.
It is 1/4. That's exactly what it is. Very good. So, I'd already found A, then I found B, now I have C. So I can write my equation, and this is what it looks like. Now, if anybody's got a question about that, I encourage you to follow Jacob's lead and go back to your notes. We did several problems like that. All right, so that's it for review for today. Now we're going to go back to our notes. And we're going to finish up section 3.5 and then start some word problems. It's going to be so fun. All right, let's look at, where are we? We are on page, or section 3.5. And we're ready for 3H, which is a logistic function. It's something we just looked at. I have a feeling we're going to need a calculator for this one, though. There is a decimal point in there, so don't lose that. It's not a very good copy. It looks like I erased. Okay. All right, our job is to solve it. You guys know how to do this. Josh Ramsey, you got an idea?
Do you multiply 1 plus 95e negative 0.6x to, yeah.
Absolutely. Very good, Josh. That's exactly what we're going to do. So when I multiply this over to here, some of you might think about it like cross multiplying. It's the same thing, whatever, however you process it. Make sure that you're taking the 150 times the 1, but the 150 times the 95 also. So 14250 e to the negative 0.6x. So we did exactly what Josh said. We got rid of our denominator by distributing it with the 150. Beautiful. Okay, Michael, do you have a thought about the next step?
No, I forget.
Okay, well, don't make it hard. This is just a normal equation, Michael. If I want to get this by itself, what am I going to need to do?
Minus the 150.
Absolutely. We're going to subtract that 150 over here. Now, See this number right here, guys, this 14,000 number? That is a coefficient that has to go away. So I'm going to now divide both sides by 14,250. Now I want to do that real quick. Okay, when you did the division, did you get like a big long decimal? Don't round that off. It's better to just leave it as 250 over 14,250. Now, if you want to reduce that, you certainly can. And remember, your calculator will do it for you. So type in, if you want to reduce it with the calculator, type in 250 over 14,250. You're going to get this decimal. Go to math. See where my fat finger's pointing right here? Math. Very first option is frac. That means fraction. Just hit enter a couple times, and it will change that into reduced form. Now, there is nothing wrong with leaving it unreduced, except it's more numbers to type in. If you want to reduce it, go ahead, and I think it came out to be 1 over 57. Is that what you got? And that's a little bit easier number to work with than 250 over 14,250. But again, it's your call. Totally your call. So we started by multiplying this over. Then with Michael's help, we subtracted the 150 and divided by the coefficient. So now here we are. Who remembers what I need to do now? Look what I'm solving for, an exponent.
ln.
I got an ln, that's exactly right. Oh, you could log if you wanted to, but that makes more work, so we'll ln. So ln 1/57th. ln cancels, negative 0.6x. So I'm going to ln, if you left it like this, that's what you're lning. I've got 1/57 divided by negative 0.6. Now I'll have to round it off because I just have to. This is the answer. And that's what I got. Could I see a thumbs up? Did I get the right answer? Are we matching? Oh, I see some thumbs up. Okay, good. Anybody have a question about that problem? We've got one more to do just like it, so we're going to practice again. But is there a question about this? Okay. Well, since we've done that one together, take a minute and give the next one a shot. I'm going to do it at the same time, but I'm not going to talk. So don't look at your screen unless you get stuck. See if you can make this one work on your own. All right, see how far you can get. Is anyone having trouble getting started? Does everybody know how to get started? I can't see everybody at once, so you need to speak up if you have a question. Haley, can you turn your camera on, honey? Thank you, sweetie. Okay, anybody got an answer yet? I saw a thumbs up a minute ago. I'm not sure what that was for. Was that because we got the right answer? Or do we have a mistake? David says we got the right answer? All right. So, who's got a question about that? We all good? Okay. All right. Well, those were a lot easier, I think, than the ones we did yesterday. Those ones we did yesterday were a little bit wacky. But finally, the moment we've been waiting for, we're going to do some applications of all this. You're probably thinking, what in the heck do we have to know all this for? Well, there are some real life problems that involve exponentials and logarithms. So let's turn to the next page of our notes, section 3.6. We did just finish 3.5, so that will be due on Tuesday. Oh no, it'll be due on Monday. What is today? Today's Thursday? Yeah, it's due Monday. Your homework's due Monday. So you'll submit it electronically anytime between now and Monday at 3:10. We do have flex today and we have flex tomorrow. So if you've looked at the 3.5 homework and you have some questions, please feel free to come in at 2:10 today using our regular class Zoom. All right, so here we go. Two things. There's a little bit of room at the top of the notes, or you can write it wherever you want. But we have two formulas that we have to memorize. And then we have two more formulas that I provide for you, and they're already in the notes later on. But the two that you're going to memorize, so put them at the top of the page, because you obviously don't have them memorized yet, are these. We're going to talk about what all these letters mean, so don't panic. And I promise that after you've done a couple of examples, you will have these down. All right. These are two formulas that deal with growth. This one deals with what we call compound growth, and it is only used with money because the only compound growth there is in the world is money. If you think about it for a minute, when you were born and you started growing, let's say you were 8 pounds when you were born, you didn't wait 3 months and all of a sudden be 9 pounds. You went through every gradual step. That is called continuous growth. So anything that grows continuously, whether it's a population, a radioactive decay in an element, anything that is changing continuously is going to use this formula. This formula is strictly for compound interest. But it's important because all of you hopefully have bank accounts and your interest is compounded monthly, annually, somehow. Daily, weekly, your interest is compounded. So this is the formula you use for most of your bank accounts. So when I read my problem, if the word compounded is in the problem, then I'm using this formula. If the word continuous is in the problem, I'm using this formula. Or if there is any kind of natural nature type situation, it's this formula. Now, here's what all the letters mean. A is the amount that you end with. So at the end of whatever time period you're talking about, that's how much you're going to have at the end of it. P is the how much we have at the start of it. The letter P stands for principal, and that is the amount of money that you begin with. So if you walk down to the bank and deposited $100, that would be your P. That's a 1, a number 1. This is your interest rate, and it is entered as a decimal. So in the problem, it will say something like 6% interest. You don't put in 6, you put in 0.06. And it's important to note there's 2 of them, and when you have a formula, each letter can stand for only one thing. So whatever you put here, you're also putting here. These are the same number. N is the number of times per year that you are compounding. So if your bank account compounds monthly, then N would be 12. If it's quarterly, then N would be 4. If it's annually, then N would be 1. Get it? Okay. And then T is the number of years. Now, for this one, everything is pretty much the same. A is the ending amount. P is the starting amount. Now, this is our letter E, Euler's constant, the base of the natural logarithms. That's an E. That is not a variable. It's a constant, just like the 1 is over here. That's a constant. R is your interest rate, entered as a decimal. And T is the time. In this formula, time can be lots of different things. For bacteria populations, it might be minutes or hours. For half-life or radioactive decay, it might be decades. In this formula, T is just whatever time is in your problem. In this formula, time is always in years. Always in years. Okay, just for fun, this is sometimes called the PERT formula. So if I say something about, oh, PERT, P-E-R-T, see, that's called the PERT formula. Okay, got all that down? No questions? Ready to do a problem? Here we go. Number 1. How long will it take for an investment of $1,000 to double if the bank pays 2.5% interest compounded quarterly? Now, did the word compounded pop out at you? I hope, because that tells you which formula to use. So here's our formula. And let's start plugging in numbers now. Where does the 1,000 go?
With P.
Yep. .5% interest will be 0.025. Everybody okay with that? 2.5%, 0.025. Now it's compounded quarterly, which means my N is going to be,
What for?
no, 4.
4.
N is the number of times a year that you compound. So quarterly means you're compounding 4 times a year. Monthly would be 12. So we got another 4 up here. Now that leaves a T and an A. What do I put in for those, T and A?
Wouldn't A be 2,000?
It
Because it's doubling.
absolutely would be. Good job, Rory. Good job. It says we want our money to double. If you're starting with 1,000, then that means you're ending with 2,000. And isn't T our unknown? Isn't that what we're trying to figure out? How long will it take? Okay. What a mess. We get to solve this guy. Anybody have an idea how to start?
Divide 1,000.
Absolutely. We got to get rid of that coefficient. We always got to get rid of this coefficient. Whether it's a logarithm equation, whatever it is, we got to get rid of it. So when we divide by thousands, we got 2. Now, just for fun, I'm going to see if that is a terminating decimal. I'm going to see if that actually works out to be something nice. 1 plus 0.025 divided by 4. Oh, it does. So my equation now looks like 2 equals 1.00625 to the 4t. Now, I don't need to do that, you guys. And there probably will be a situation where I can't do it. But it's just easier for me to process the equation when there's a number there instead of all this. If you want to leave all that, it's perfectly okay. We're going to get exactly the same answer because I didn't round this off. But how in the heck am I going to solve that?
Would you take the log so that the exponent comes down?
Exactly, Grace. This is why we need logarithms, so that we can solve a problem where the variable is an exponent. Now, she said log. I always do that. But if there's an ln freak out there, could you ln both sides? Sure. There's no benefit to it because we don't have an e. But you could certainly ln both sides. And that, whether you log or ln, is going to pull that 4t out in front. This is what we are solving for, right here, t. So we're going to have to divide by the 4 and divide by the log. Would you agree with that? Now, when you type this into your calculator, I need you to recognize that since you are dividing by 2 things, you got to put that in parentheses. If you want to divide by each one separately, that'll be okay. But if you're going to divide by them all at once, you got to have parentheses around it. So log 2, close the parentheses, divided by parentheses 4 log 1.00625. I got 27.81 years. Now, I might have typed that in wrong. Let's double check. Anybody agree with me? No? Oh, thumbs up, thank you. There's a couple of them. Good, good, good. So let's shoot. Let's practice typing that in. Let's shoot for this answer. We think it's right. Does anyone have a question about any aspect of this problem beginning to end? Why we picked the formula we picked? Why we put the number?
Do you have to plug it back in to see if it works or not?
No, you do not have to. Grace, checking your answer is always a good idea, but this kind of problem will not have an extraneous root. Logarithm equations. Now, this isn't a logarithm equation. This equation was exponential. We put logarithms into it, but you could have extraneous roots if the original problem has logs in it.
Okay. Thank you.
Good question. All right, let's try the next one. How much will be in the account at the end of 10 years if $1,230 is invested at 3.125% interest compounded monthly? Okay, compounded monthly, I'm using the same formula. Remember, if you are compounded a finite number of times, monthly, daily, yearly, quarterly, this is your formula. How much will be in the account at the end of 10 years? Okay, so I know I'm starting with 1230. I know my interest rate is 0.03125. Compounded monthly means my N is what? Yep, 12 months in a year. And I'm doing it for 10 years. And I want to know how much I have at the end, right? Now, are we going to need logarithms to do this problem? No, very good, Caleb. The only time we need logarithms to solve the problem is if the variable is an exponent. Otherwise, you're just going to type it in. Now, I do recommend going ahead and simplifying this exponent, so I'm going to think of that as 120, and then I'm just going to type it in exactly the way I wrote it. 1230 parentheses 1 plus 0.03125 divided by 12, close parentheses, raised to the 120th power. Remember, this is your raised button. I got $1,680.53. Sometimes there can be questions about rounding, but never in a money problem, right? Cents is about as far as we can go.
Mrs. Ford, where did you get the 12 from?
It says compounded monthly.
Uh-huh.
How many months in a year?
12.
Yep, and N stands for the number of times a year we compound. So if we're compounding monthly, that's 12 times a year.
Oh, okay.
All right, everybody get 1,680. Number 3, how long will it take for a population of 450 geosites to double if their growth constant is 0.123? That's a PERT problem, folks. Does everybody recognize it? It's a population growth. It grows on a continuum. It's constantly growing. So it's the continuous growth formula. You are never going to use this problem in a non-money situation. This is a money formula. All right, let's see what we got here. How long will it take for a population of 450? So we're going to start with 450, and it's going to double, so we're going to end up with 900. Okay, if we start with 450, we end with 900. The growth constant is 0.123. So this population grows at a 12.3% rate. And we want to know how long it's going to take. Everybody okay with that? All All right, here we go. Hey, Zeus, step one. What do you think we ought to do first?
Then we should divide the 450.
You are exactly right. So if I divide by 450, that's what I'm going to get. Look where that variable is. It's an exponent. Solar, what am I going to need to do since my variable is up there in the exponent spot? Solar, my friend. Oh, there you are. Wake up, sunshine. What do I need to do to solve for t, Solar? Do you have an idea? It's an exponent.
ln.
Exactly. Exactly. Thank you. We're going to ln both sides. So ln2, that cancels, equals 0.123t. So I'll divide ln2 by 0.123. Can't miss this one, just make sure you close that parentheses. Did you get 5.64 years? All right, so far so good. Anybody need to stop or ask a question here? All good? All right, number 4. How much do I need to deposit in an account paying 4% interest compounded continuously? That's a PERT. That word continuously is a flag. That's PERT. If I want to have $35,000 in exactly 10 years. Okay. What do I put where? I got a bunch of numbers here. Where do I put anything?
Do you put the 1,000 in for A?
Absolutely. That's how much you want to end up with. Good. By the way, Jacob, you can talk again anytime you want, okay? All right, what else? What other numbers go where?
With the 4%, you turn that into a decimal and you put that into R.
Mm-hmm. Got it?
10 for T.
Yep. And remember, E is not a variable. Isn't P my variable this time? How much do I have to start with? Now notice, guys, the variable is not an exponent. I'm going to go ahead and multiply those and get 0.4. But the variable is not an exponent. You do not use logarithms. You only use logarithms if your variable's up here. My variable is here. All I need to do is divide both sides by e to the 0.4. That's going to give me what my p-value is. So I'll take 35,000 divided by, now to get e, you do second ln, and that will pull an e up on your calculator, and it asks you what power, so you just put in 0.4, and the answer, you would have to deposit $23,461.20. Everybody getting that?
I got 641.
Oh. You mean it's the total answer?
Yeah.
Okay, well, first of all, I want you to think about that answer. If you could deposit $6,000 in a regular bank account and in
You
10
forgot
years
the point 4, bro.
have 35,000,
Oh, right.
you would be all set. So your answer needs to be reasonable too, but you figured out your error? Somebody figured it out for you?
Yeah.
All right, good deal. All right, one more. Find the decay constant of an element if its half-life is 10.2 years. So find the decay constant of an element if its half-life is 10.2 years. Which formula?
That would be the A equals P
Yep.
times E.
That's right. This is a PERT problem. Remember, we only use the other formula when we are compounding a certain number of times a year. Now, from biology class, what does half-life mean? What do we mean when we say half-life?
The amount of time it takes to become half.
Exactly. So we know that the amount of time it takes is 10 years. And if we're going to become half, then doesn't that mean whatever I start with, I'm going to end up with half of it? Now, they didn't tell me how much I started with, but it doesn't matter. I just need to make sure I'm ending up with half of what I started. So I like to start with 10, then I'll end up with 5. Just hang with me for a minute and I'll show you in a second why it doesn't make a single bit of difference. And I know I'm looking for my rate, right? I'm looking for my decay rate, my decay constant, if time is 10.2. What is the first step in solving that equation? Dividing out the 10. Now, when I divide by 10, isn't that going to give me 1/2 over here? So let's suppose you started with 1,000. Then you would be ending up with 500. What's going to happen when you divide by your 1,000? Aren't you going to get exactly the same equation? So the point is, it doesn't matter what you start with. Pick something to start with and then end up with half of it. Now what do?
Signs.
Yeah, we got to ln. Guys, we keep talking about this, or I keep talking about it. When your variable is the exponent, you're going to need some kind of logarithm. If your variable is the exponent. All right, so ln 0.5 equals 10.2r because that cancels. And we have ln 0.5 divided by 10.2. And this is going to be our answer, and then we're going to be done. So what do we get? ln 0.5. Please don't forget to close the parentheses. Oh my goodness. Did you get negative 0.0680 if I rounded off to the 10,000?
Yes.
Okay, wait a second. Why is that negative? Should that be negative?
Yes, it's decreasing.
Exactly. It's a decay constant. So it functions like an interest rate in a money problem. But if your amount is going down, then it makes sense that that you have a negative growth constant. Decay is negative growth. Well, I've packed a bunch of stuff at you again today. Remember, we're here in Flex at 2:05 if anybody wants to come back. Otherwise, people, I don't think I see you tomorrow. So have a great weekend, and I will see you Monday. Okay?
Thank you.
All right,
Thank
bye-bye.
Thank you, Mrs. Ford.
See ya.
Yeah.
Bye-bye.